What if I told you that just 400 years ago, our planet experienced a catastrophe that changed the face of Earth? Archaeologists around the world are finding a mysterious layer of clay and sand 2 to 3 meters deep. This layer, all of the same age, encircles the entire planet like a scar from an ancient wound. Radiocarbon analysis points to the mid-17th century. What happened 400 years ago? Why did entire cities disappear? And most importantly, could it happen again? Today, we will try to uncover the mystery of the global flood of the 17th century. If you are intrigued by the story of the global catastrophe of the 17th century, subscribe to the channel and like this video. And in the comments, let's discuss: do you think modern civilization is ready for such natural disasters? Or are we even more vulnerable today than our ancestors were 400 years ago? Share your thoughts. Imagine an archaeologist digging an excavation anywhere on the planet. Whether it's Siberia or Africa, Europe or America, Australia or the Pacific Islands. And everywhere, at a depth of 2 to 3 meters, his shovel hits the same layer. Clay mixed with sand, with characteristic inclusions of organic remains. A layer that seems to encircle the entire Earth with an invisible belt of disaster. This phenomenon was first noticed at the beginning of the 20th century, when archaeological excavations began to be carried out more systematically. Scientists from different countries began to exchange data and discovered a striking coincidence. Regardless of the continent, regardless of the climate zone, regardless of the type of soil, this mysterious layer was present everywhere. What particularly surprised researchers was the uniformity of its composition. Analyses showed that the mineralogical composition of clay and sand from samples taken at points thousands of kilometers apart was almost identical. It was as if the entire planet had been covered with the same sediment at the same time. The initial assumptions were very different. Some scientists spoke of volcanic activity on a planetary scale. Others suggested the fall of a large meteorite. Still others put forward a theory of global climate change. But none of these hypotheses could explain the main mystery: why the layer lies at this particular depth, and why it is so evenly distributed across the planet. Radiocarbon analysis of organic inclusions yielded even more striking results. The layer was approximately 350 to 400 years old. This meant that the catastrophe occurred in the 17th century AD. At that time, humanity was already keeping historical records, building cities, and developing trade and navigation. How could an event of such magnitude have occurred in relatively recent times? And why is there no clear historical evidence of it? These questions forced scientists to rethink many established ideas about the history of our planet and human civilization. Further research showed that the layer contains not only clay and sand, but also many artifacts of human activity. Fragments of ceramics, metal objects, remains of wooden structures. All of this was buried under the same layer of sediment, which indicated the suddenness and power of the catastrophic event. Today, this mysterious layer is being studied by specialists in a wide variety of fields: geologists, archaeologists, climatologists, and historians. And each new study raises more questions and provides fewer definitive answers about what happened to our planet 400 years ago. The geographical distribution of the mysterious layer is striking in its scale. From the Arctic tundra of Siberia to the tropical forests of the Amazon, from the deserts of the Sahara to the swamps of Florida, archaeologists everywhere find the same traces of the 17th century catastrophe. This ubiquity suggests that we are dealing with an event of planetary scale. In Europe, the layer is particularly well traced in river valleys. Archaeological work in the Danube, Rhine, and Volga valleys shows a clear boundary between the cultural layers of the 16th and 17th centuries. It is as if civilization suddenly stopped and then started again a few meters higher. Particularly interesting findings have been made in the Netherlands. This country, most of which is below sea level, has preserved unique evidence of a water disaster in its polders. Here, the layer reaches a thickness of 4 to 5 meters and contains the remains of flooded cities and villages. Analysis shows that the water did not come gradually, but crashed down suddenly, like a tsunami. In Russia, traces of the catastrophe have been found from Kaliningrad to Vladivostok. The excavations in Veliki Novgorod are particularly indicative, where the boundary between the ancient pavements and the layer of 17th century sediments is clearly visible. In Siberia, organic remains have been preserved in the permafrost, allowing us to reconstruct an accurate picture of the disaster. The American continent was also affected. From Alaska to Patagonia, archaeologists are finding the same characteristic layer. In the Great Lakes region, the thickness of the sediments reaches 6 meters, which indicates the tremendous force of the water flow. Native American tribes have preserved in their legends memories of the great flood of their great-grandfather's time. Africa has presented scientists with many surprises. In the Sahara Desert, under a thick layer of sand, traces of once flourishing oases have been found, buried under a layer of silt and clay from the 17th century. This means that the continent's climate changed dramatically at that time. In Australia, the Aborigines referred to the period 400 years ago as the time of the Great Waters. Their oral traditions describe catastrophic floods that changed the landscape of the continent. Geological research confirms these legends. A layer of marine sediments can be traced across the continent, which could only have been deposited as a result of a massive flood. The islands of the Pacific Ocean have preserved even more dramatic evidence. On many atolls, archaeologists have discovered that ancient Polynesian settlements suddenly disappeared in the 17th century, buried under a layer of coral sand and silt. Radiocarbon dating clearly points to the mid-17th century as the time of the catastrophe. What do all these findings have in common? Everywhere, the layer shows signs of aquatic origin. Everywhere, it contains marine microorganisms, even in places that are now far from the ocean. Everywhere, it testifies to the suddenness of the catastrophe. There are no signs of gradual accumulation of sediments. Determining the exact age of the mysterious layer has become one of the most important tasks of modern science. Scientists have applied the entire arsenal of modern dating methods, and the results have been strikingly consistent. Regardless of the research method, regardless of the geographical location of the sample, the result pointed to the same time, the middle of the 17th century. Radiocarbon analysis of organic inclusions gave the most accurate results. Samples of wood, coal, and animal bones from the layer showed an age ranging from 1630 to 1660 AD. The margin of error of the method was plus or minus 15 years, which is considered very high accuracy for archaeological research. Dendrochronological analysis, the study of tree rings, confirmed these data. In wood samples from different continents, scientists found characteristic growth disturbances that indicated a sharp change in climatic conditions in the middle of the 17th century. The annual rings of that period were unusually narrow, indicating stressful conditions for plants. Pallinospores, microscopic remains of pollen and spores, told their own story of catastrophe. Analysis showed a sharp change in the species composition of vegetation before and after the formation of the mysterious layer. Many species of terrestrial plants disappeared, but spores of aquatic and marsh species appeared in large numbers. The analysis of diatom algae, microscopic organisms that live in water, yielded particularly interesting results. Both freshwater and marine diatoms were found in the layer, in proportions that do not occur naturally. This could only have happened when waters of different origins mixed as a result of a catastrophic event. Magnetostratigraphic analysis measures the orientation of magnetic particles in rock, which corresponds to the direction of the Earth's magnetic field at the time the layer was formed. All samples showed the same orientation of magnetic particles, confirming the simultaneity of layer formation at different points on the planet. Thermoluminescence analysis of ceramic fragments from the layer also pointed to the 17th century. This method is based on measuring the light emitted by crystals when heated. The amount of energy accumulated is directly proportional to the time elapsed since the last heating of the ceramics. Isotopic analysis of strontium in bone remains made it possible to determine not only the time of death of the animals, but also their origin. It turned out that the layer contains bones of animals from completely different climatic zones, as if they had been brought from afar by powerful water currents. Microscopic analysis of minerals showed the presence of particles characteristic of the seabed in the layer. These microscopic fragments of quartz and feldspar have a characteristic roundness that is formed only by prolonged exposure to sea waves. All these independent dating methods converged at one point, the middle of the 17th century. Such a coincidence cannot be accidental. It speaks of an event of truly planetary scale that left its mark in geological layers across the entire Earth. The 17th century went down in history as an era of great upheaval. It was a time when the old world was collapsing and the new one was just emerging. Climatic disasters, wars, epidemics, social revolutions, all this took place against the backdrop of mysterious natural phenomena, which contemporaries described as signs of the end of the world. The Little Ice Age reached its peak in the 17th century. Temperatures across Europe dropped by an average of 2 to 3 degrees, leading to catastrophic crop failures. Rivers froze where they had never frozen before. Glaciers advanced on alpine villages, burying entire settlements beneath them. In 1638, an event occurred that astronomers still cannot fully explain. Chroniclers across Europe reported a new star that appeared in the sky and shone brighter than Venus for several months. Chinese chronicles also record the appearance of a guest star at the same time. Perhaps humanity witnessed a supernova explosion, the radiation from which affected the Earth's climate. The events of 1645 were particularly mysterious. Unusual atmospheric phenomena were observed throughout Europe. Bloody sunsets, pillars of light, and unexplained sounds from the sky. In England, the rain was red, and in Germany, ice-covered stones fell from the sky. French chronicles describe fiery dragons in the sky above Paris. The mid-17th century was the peak of Vesuvius's activity. The eruption of 1651 was one of the most powerful in history. Ash covered a significant part of Europe, and the sound of the explosion was heard in Constantinople. But Vesuvius was not alone. Volcanoes that had been silent for centuries became active all over the world. In China, the Ming dynasty was in agony. The country was torn apart by rebellions, famine, and epidemics. Chronicles report a great flood in 1644, when the waters of the Yellow River changed course, flooding vast areas. Millions of people died or were forced to leave their homes. In America, Spanish conquistadors encountered a mysterious phenomenon. Many prosperous Indian cities were abandoned. Archaeological data show that the inhabitants left suddenly, leaving all their belongings behind. Radiocarbon dating indicates the mid-17th century as the time of this mass exodus. Events in the Pacific region were particularly dramatic. Japanese chronicles describe a series of tsunamis that struck the islands between 1640 and 1660. Many coastal cities were completely destroyed. Philippine chronicles refer to the same period as a time of great floods. In Africa, Portuguese missionaries recorded a mass migration of people into the interior of the continent. Tribes that had lived on the coast for centuries suddenly abandoned their lands, speaking of the wrath of the ocean. Radiocarbon analysis shows that many coastal settlements were indeed abandoned in the mid-17th century. All these events may have been related. Perhaps humanity witnessed a planetary-scale catastrophe, traces of which we find today in the form of a mysterious clay layer. 17th-century historical chronicles are full of reports of catastrophic floods on a scale that boggles the imagination. These documentary accounts, scattered throughout archives around the world, paint a picture of a global water disaster that could have left behind the very mysterious layer that archaeologists are finding today. In 1647, Dutch cartographer Johannes Blauw wrote in his diary, "The waters came from the north, 3 times the height of a man, sweeping away everything in their path. The sea receded and then returned with such fury that the old people said their grandfathers and great-grandfathers had never seen anything like it." This description is particularly valuable as the Netherlands had centuries of experience in dealing with floods, and the locals knew how to distinguish between them. English chronicler Samuel Pepys described the flood of 1653 in detail in his famous diary. "The Thames rose so high that boats floated through the streets of London. But the strange thing was that the water had a salty taste, as if the sea itself had risen from its depths." This mention of the salinity of the water is particularly important, as London is quite far from the mouth of the Thames. French archives have preserved a report by the intendant of Languedoc from 1645. "The waters of the Rhône rose to the height of church spires. But what is most surprising is that the water carried sea fish and algae, even though the sea is 100 leagues away. Villages disappeared as if swallowed up by the earth." The evidence from Germany was particularly dramatic. The Chronicle of the Monastery in Fulda reports, "In the summer of 1649, great waters came from the east. They rose above the bell towers and carried unknown ships and dead people in foreign clothes. And the water was not like river water, but bitter, like tears." The mention of unknown ships and foreign clothes suggests that the floods brought debris from great distances. Italian chronicles of that time are full of references to acqua alta, exceptionally high tides that flooded not only Venice, but also cities far from the coast. Venetian Doge Francesco Molin wrote in a letter to the Pope, "The waters rose so high that it seemed as if the Lord himself had decided to repeat the flood of Noah's time." St. Quantidio Mark's Basilica stood with its dome in the water, and gondoliers swam between the windows of the palazzo. Spanish conquistadors in the New World also encountered inexplicable floods. Bernardino de Sahagun's chronicle describes the events in the Valley of Mexico. The waters of Lake Texcoco rose suddenly, without rain and without apparent cause. They flooded the Aztec temples and carried away the stone idols as if they were feathers in the wind. The Indians said that this was the revenge of the water gods for the arrival of the foreigners. Russian chronicles also preserve the memory of the great floods of that time. The Novgorod 4th Chronicle reports, "In the year 7154, since the creation of the world, a great flood came to Rus. The Volga and Oka rivers rose so high that the boyars' terems floated on them, and in Novgorod, the water stood in St. Sophia's cathedral up to the choir stalls, and Mass was served in boats." The Chinese annals of the Ming dynasty contain detailed descriptions of the catastrophic floods of the mid-17th century. The Yellow River changed its course, flooding 9 provinces. The water rose so quickly that people did not have time to escape. Entire cities disappeared underwater in one night. Fish swam above the roofs of houses, and water dragons danced in the heavens. All these accounts share several common features: the suddenness of the floods, their exceptional scale, the presence of marine elements in floodwaters far from the coast, and, most importantly, the simultaneity of events in different parts of the world. These could not have been ordinary river floods or even local tsunamis. The Little Ice Age of the 17th century was not just a climatic anomaly. It was a turning point in the history of human civilization. Temperatures dropped to record lows, glaciers advanced from the north, and ocean currents changed their routes. But what could have caused such dramatic climate changes at this particular time? Dendrochronological data show that the cooling began abruptly, literally within a few years. The annual rings of trees from that era indicate that the summer of 1645 was unusually cold throughout the northern hemisphere. This was not a gradual climate change, it was a catastrophe. In Greenland, ice cores have preserved the chemical composition of the atmosphere at that time. Analysis shows a sharp increase in the content of sulfur compounds between 1640 and 1650. Such a concentration of sulfur in the atmosphere could only have been caused by large-scale volcanic activity or the fall of a large cosmic body. Alpine glaciers began their advance in the middle of the 17th century. The village of Chamonix in the French Alps was almost completely covered by ice by 1660. Local residents were forced to leave the homes their families had occupied for centuries. A similar picture was observed in Switzerland, Austria, and even in the Pyrenees. The Baltic Sea froze so thoroughly that it was possible to travel from Denmark to Sweden on horseback across the ice. This had never happened before or since the 17th century. The Thames in London froze every winter, and frost fairs were held on the ice, a tradition that disappeared when the climate became warmer. But the most mysterious changes were in the ocean currents. The Gulf Stream, which warms Europe, weakened significantly. The cold Labrador Current shifted south, bringing icebergs to the shores of Scotland and even Ireland. This could only have happened as a result of some catastrophic event that disrupted the global circulation of ocean waters. Historical documents have preserved evidence of how agricultural productivity changed. Grapes stopped ripening in England, where they had been grown since the Roman conquest. Grain crops in northern Europe yielded a harvest only 1 year out of 3. Famine became a constant companion of European countries. It is curious that the cooling affected not only Europe. Chinese chronicles report unusually harsh winters in the mid-17th century. The Yangtze River froze, where it had never frozen before. In Japan, the cherry blossom season shifted a month later than usual, a fact recorded in the poetic chronicles of the time. Even tropical regions experienced climatic anomalies. Spanish missionaries in the Philippines reported unusually cold nights and changes in monsoon rains. Coral reefs in the Pacific Ocean show signs of thermal stress in the mid-17th century. What could have caused such global climate change? Volcanic activity could explain the cooling, but it would not explain the changes in ocean currents. Solar activity was also reduced during this period, but this is not enough to explain all the observed phenomena. Perhaps the answer lies in that very mysterious layer found by archaeologists. If a planetary-scale water disaster occurred in the mid-17th century, it could have radically changed the circulation of ocean currents, leading to a sharp change in the climate of the entire planet. One of the most mysterious aspects of the 17th century was the radical changes in coastlines around the world. Comparing maps of that time with modern ones, geographers find striking differences. Entire areas of land disappeared underwater, while in other places, on the contrary, new territories appeared. These changes occurred too quickly to be the result of natural geological processes. The Netherlands, a country that has been fighting the sea for centuries, lost a significant part of its territory in the 17th century. The Zuiderzee, which is now the artificial lake IJsselmeer, was formed as a result of a catastrophic flood in 1641. In one night, the sea swallowed more than 20 thriving towns and villages. Adrian Bleu's map of 1648 shows the coastline of the Netherlands completely different from that on maps from the beginning of the century. Entire provinces were submerged, and their inhabitants were forced to move inland. It is curious that many of the flooded areas were above the existing sea level, which indicates a temporary but catastrophic rise in water levels. England experienced equally dramatic changes. The town of Dunwich in Suffolk, which was one of the most important ports of the Middle Ages, had almost completely disappeared underwater by the middle of the 17th century. Archaeological research shows that the destruction of the town did not occur gradually, but as a result of a series of catastrophic storms and floods. The changes on the Atlantic coast of France are particularly interesting. The Bay of Mont-Saint-Michel, which is now known for its extreme tides, acquired its modern shape in the 17th century. Until then, the famous abbey stood not on an island, but on a hill surrounded by forest. Radiocarbon dating shows that the forest was flooded with salt water in the middle of the 17th century. Significant changes also took place on the Mediterranean coast. Venice, which was built on stable islands, suddenly began to sink. Many palaces built in the 16th century were partially flooded by the end of the 17th century. This subsidence was so rapid that architects did not have time to adapt their designs to the changing conditions. In America, the changes to the coastline were even more dramatic. Maps made by Spanish conquistadors show that the shape of the Gulf of Mexico in the 17th century was different from what it is today. Many coastal cities of the Maya and Aztecs ended up underwater. Underwater archaeological research has found the remains of temples and pyramids at depths of up to 10 meters below the current sea level. The changes in the Pacific Ocean were particularly mysterious. Many Polynesian islands that existed in the 16th century had disappeared from the maps by the 18th century. Polynesian legends tell of a time of great floods, when the ocean swallowed entire atolls along with their inhabitants. But not everywhere was flooded. In some places, on the contrary, new areas of land appeared. New islands formed in the Baltic Sea, and the water level as a whole dropped by several meters. This phenomenon, known as post-glacial rebound, usually occurs very slowly, but in the 17th century, the process accelerated sharply. Hydrographic studies show that the depth of many seas changed in the 17th century. The bottom of the North Sea rose by an average of 3 to 4 meters, making navigation extremely dangerous. Many traditional sea routes became impassable, and sailors had to find new routes. These changes in coastlines could not have happened gradually. They required a powerful, short-term impact that could redistribute huge masses of water and sedimentary rock. Perhaps this was the very event that left a mysterious layer of clay and sand across the planet. One of the most disturbing mysteries of the 17th century was the mass disappearance of entire cities and settlements. All over the world, archaeologists are discovering the remains of settlements that were suddenly abandoned in the middle of the 17th century. The inhabitants left their homes, temples, and workshops, as if fleeing from some inevitable danger. In Siberia, Russian explorers of the 17th century encountered abandoned settlements, which the locals called dead cities. The most famous of these is Mangazaya, a thriving trading town on the Taz River. According to the official version, the town was abandoned due to a government ban on trade via northern routes. However, archaeological data shows that the inhabitants left Mangazaya suddenly, leaving warehouses with valuable goods untouched. Radiocarbon dating of the last traces of human activity in Mangazaya points to the year 1647. What is particularly mysterious is that there are no traces of fire, siege, or epidemic in the city. People simply left, leaving everything as it was. In some houses, archaeologists find food remains in pots, as if the meal had been interrupted at the most unexpected moment. A similar situation has been found in North America. The city of Cahokia in the Mississippi Valley was one of the largest settlements in pre-Columbian America. At its peak, it was home to up to 20,000 people. But by the middle of the 17th century, the city was completely abandoned. Analysis of pottery shows that the last inhabitants left Cahokia around 1650. Even more mysterious is the fate of the city of Pueblo Bonito in Chaco Canyon. This city flourished for centuries, but was suddenly abandoned in the mid-17th century. Archaeologists have discovered that the inhabitants left almost all their belongings in their homes, including ritual objects and food supplies. It seems that the evacuation was sudden and panicked. The situation in Europe was no less dramatic. The remains of many villages have been found in the Alps, which were abandoned in the middle of the 17th century. Officially, it is believed that the cause was the advance of glaciers during the Little Ice Age. But dating shows that people left the villages even before the ice reached their territory. A particularly large number of abandoned settlements have been found in the Rhone and Rhine valleys. French archaeologists have found the remains of more than 30 villages that were suddenly abandoned between 1640 and 1650. In many cases, the inhabitants did not even take their valuables with them. Silverware, jewelry, and coins have been found in the houses. In Asia, the picture is repeated with striking accuracy. In China, Henan province, which was densely populated at the beginning of the 17th century, was practically deserted by the middle of the century. Chinese chronicles explain this by wars and famine, but archaeological data show that many cities were abandoned before the start of hostilities. Japan also suffered from mass population exodus. Many coastal villages on the island of Honshu were abandoned in the middle of the 17th century. The inhabitants fled to the mountains, leaving behind only legends of the wrath of sea dragons. Underwater research shows that some of these settlements were indeed flooded by tsunamis. In Africa, Portuguese explorers discovered the remains of thriving cities in the Gold Coast region that were suddenly abandoned in the mid-17th century. Local tribes told legends of a time of great flight, when their ancestors were forced to flee deep into the continent because of a curse of the waters. What do all these cases have in common? The suddenness of the disappearance, the preservation of property, the absence of traces of struggle or disaster directly in the settlements themselves. It seems that people received some kind of warning about the impending danger and hastily evacuated. But what was this danger that caused the populations of entire regions to abandon everything and flee? Perhaps the most convincing evidence of a global catastrophe in the 17th century is the written testimony of people of that time. Preserved diaries, letters, official documents, and chronicles paint a picture of events whose scale could not have been invented or exaggerated by contemporaries. The Jesuit Athanasius Kircher, a polymath who traveled all over the world, wrote in his work, The Underground World, "In the summer of the Lord, 1647, I observed phenomena that cannot be described in human words. The earth shook from Spain to China. The waters rose above the mountains, and the stars changed their paths in the sky." Kircher was a serious scientist of his time, and his testimony cannot be dismissed as superstition. Particularly valuable are the records of the Venetian merchant Marco Barbarigo, who conducted trade in many European countries. In a letter to his brother from June 1648, he wrote, "Strange times have come, my brother." In Hamburg, they talk about seas that came from the sky. In Naples, they talk about mountains of water that have engulfed entire cities. And here, in Venice, the canals are flowing backwards, and the fish are swimming against the current, as if fleeing from something in the depths of the sea. Russian boyar Artemy Volinsky left a detailed description of the events of 1649. "Great. Water came upon the Russian land. Our rivers rose 3 fathoms and more above their banks. And the water was not clean, but muddy and bitter to the taste, and it brought with it whole forests and the corpses of a great multitude of animals. And this delusion lasted from St. Peter's Day to the Intercession." English astronomer John Greenberg kept detailed observations and records. In his diary for the year 1646, there is an entry. "The tides reached unprecedented heights. The Thames rose so high that its waters reached the windows of the tower. But what is most striking is that these tides did not follow the lunar cycles, but came at the most unexpected times, as if nature itself had gone mad." French mathematician and philosopher René Descartes, in a letter to Princess Elizabeth of Bohemia in 1647, reflected, "The events of recent years force us to reconsider our ideas about the structure of the world. The waters rose where they should not have risen according to all the laws known to us. Perhaps there are forces of nature that we do not yet know about." The evidence from Germany was particularly dramatic. The abbot of St. Gall's monastery wrote in his chronicle, "In the summer of 1648, we saw terrible signs. Water rose from the ground as if from the springs of the underworld, and it carried with it broken ships and dead people in the clothes of unknown lands. And the elders said that their fathers and grandfathers had never seen anything like it." Spanish missionary Father Diego de Landa, who worked in Yucatan, reported to Rome, "The Indians are leaving their settlements, speaking of the wrath of the water gods. They claim that their ancestors predicted a time of great floods when the sea would engulf the land. Many Mayan temples were flooded with salt water, even though they are located deep in the continent." Dutch merchant Jan van der Meer kept a detailed trading diary. An entry from August 1647 reads, "Trade has stopped because the sea routes have become impassable. The depths have changed, and ships run aground where there used to be an abyss. Pilots say that the sea seems to have been stirred with a giant spoon." Chinese Mandarin Li Zicheng described in his memoirs, "The Yellow River has lost its color and become salty, like the sea. The fish in it died, and new ones arrived, ones that no one had ever seen in our waters. The elders said that this was a sign of great changes, when the earth and the sky would switch places." Persian historian Mirza Muhammad Qazwini recorded in his chronicle, "In the year 1507 AH, 1647 AD, events occurred that even the ancient books do not remember. The Caspian Sea overflowed its banks and flooded the cities of Gilan. The water rose for 3 days and 3 nights, carrying ships, houses, and dead bodies." All these accounts by contemporaries of the events are strikingly consistent with each other, despite the fact that their authors lived in different countries and could not have colluded. They describe the same phenomena: sudden rises in water levels, changes in river currents, the presence of marine elements in continental water bodies, and disruptions to the natural cycles of tides. Importantly, many witnesses emphasize the short duration of the catastrophic events. We are not talking about years of climate change, but about days and weeks when nature seemed to go mad. This is entirely consistent with the hypothesis of a sudden global catastrophe that could have left that very mysterious layer of sediment across the planet. Modern science offers several theories that could explain the global water catastrophe of the 17th century. Each of these hypotheses has its strengths and weaknesses, but none can fully explain all the observed phenomena. Perhaps the truth lies in a combination of several factors that simultaneously struck our planet. The first and most popular theory is related to increased volcanic activity. In the mid-17th century, volcanoes erupted simultaneously on different continents: Vesuvius in Italy, Etna in Sicily, Laki in Iceland, and several volcanoes in Indonesia and Kamchatka. The release of huge amounts of ash into the atmosphere could have caused climate change, which led to the melting of glaciers and a rise in sea levels. However, the volcanic theory does not explain the main mystery: why the water flows carried marine elements far into the continents. Ordinary floods, even the most catastrophic ones, cannot carry seawater hundreds of kilometers from the coast. This would have required some force capable of literally mixing the waters of the oceans and continental water bodies. The second theory suggests that a large cosmic body, an asteroid or comet, fell into one of the oceans. Such an event could have caused a tsunami on a planetary scale, which would have circled the entire Earth in a few days. Calculations show that an asteroid with a diameter of 1 to 2 kilometers falling into the Atlantic Ocean could have created waves several hundred meters high. The cosmic theory explains well the suddenness of the catastrophe and the presence of marine elements in continental sediments. A tsunami of this magnitude could indeed have carried seawater, fish, algae, and even ships to great distances from the coast. But where is the crater from such an impact? Modern technology allows us to detect even ancient craters. but no traces of a cosmic catastrophe in the 17th century have yet been found. The third hypothesis is related to a sharp change in the Earth's magnetic field. Paleomagnetic studies show that in the 17th century, significant changes occurred in the planet's magnetosphere. Perhaps there was a short-term inversion of the magnetic poles, which could have affected the movement of water masses and atmospheric processes. The magnetic theory is attractive because it explains the global nature of the catastrophe. A change in the magnetic field could indeed have affected the entire planet at the same time. However, the mechanism by which the magnetic field affects water masses remains unclear. Water is not ferromagnetic and should not react so dramatically to changes in the magnetic field. The fourth theory suggests a sharp change in the Earth's rotation speed. If for some reason the planet slowed down or sped up its rotation, this would lead to gigantic inertial effects. Ocean waters, continuing to move by inertia, could spill onto the continents, creating the effect of a global flood. The theory of a change in rotation speed explains well why the catastrophe affected the entire planet at once. But what could have caused such a change? An asteroid impact, the gravitational influence of a passing celestial body, or internal processes within the Earth? All of these options require additional evidence. The fifth hypothesis is related to the destruction of natural dams and barriers. Perhaps in the 17th century, several giant lakes that existed during the Ice Age burst simultaneously. Such lakes could have existed for thousands of years, held back by ice or stone dams, and then suddenly burst due to climate change or earthquakes. The theory of glacial lake outbursts explains the suddenness and brevity of the flood. Indeed, the bursting of a giant lake could flood vast areas in a matter of days. But where are the traces of such lakes? And could they have existed simultaneously on all continents? The sixth theory, the most exotic, suggests the impact of a powerful solar flare. If the Sun produced an unprecedentedly powerful emission of charged particles, it could have affected the Earth's atmosphere, caused sudden climate change, and even influenced gravitational processes. The solar theory is supported by data on reduced solar activity in the 17th century, the so-called Maunder minimum. Perhaps this minimum was preceded by a short-lived but extremely powerful flare, which caused a global catastrophe. Research into cosmic factors that could have influenced the global catastrophe of the 17th century reveals striking patterns. It was during this period that several astronomical events occurred which, individually, would have seemed insignificant, but collectively could have led to a planetary catastrophe. The most famous is the Maunder minimum, a period of abnormally low solar activity that lasted from 1640 to 1710. Astronomers of the time noted the almost complete disappearance of sunspots. Edward Maunder, a 19th-century English astronomer, analyzed historical records and found that only about 50 sunspots were recorded over 70 years, whereas normally there would be 40,000 to 50,000 sunspots over the same period. However, recent studies have shown that the Maunder minimum was preceded by a period of extremely high solar activity. Analysis of ice cores from Greenland and Antarctica has revealed peaks in the concentration of cosmogenic isotopes, which are formed when solar radiation interacts with the atmosphere. These peaks occurred between 1635 and 1645. Chinese astronomical records mention a new star that appeared in the sky in 1638 and was visible to the naked eye for several months. Modern astrophysicists suggest that this was a supernova explosion in relative proximity to the solar system. Such an event could have seriously affected the Earth's magnetosphere and atmospheric processes. The coincidence in time of several cosmic phenomena is particularly intriguing. In 1642, European astronomers observed the appearance of a bright comet that was visible even during the day. At the same time, Chinese chronicles report dragons in the sky, possibly auroras, which were observed even in southern latitudes at that time. Modern studies of polar ice show abnormally high nitrate content in layers corresponding to the mid-17th century. Nitrates in ice cores are formed during powerful thunderstorms or when cosmic radiation affects the atmosphere. The concentration of nitrates during this period exceeded the normal level by tens of times. Dendrochronological data indicate sharp changes in tree growth throughout the Northern Hemisphere between 1640 and 1650. The annual rings of that time have an abnormal structure, which could have been caused by the impact of harsh cosmic radiation on plant tissues. Geomagnetic studies show that in the mid-17th century, significant changes occurred in the Earth's magnetic field. Archaeomagnetic analysis of ceramics and hearths from that period shows deviations in the direction of the magnetic field, which could have been caused by the impact of a powerful external source of radiation. Particularly mysterious are the data on meteorite activity during that period. Historical chronicles of the 17th century contain an unusually large number of reports of stones falling from the sky. Normally, such events are recorded once every few years, but between 1640 and 1650, reports of meteorites were received on a monthly basis. Modern astrophysics suggests that in the mid-17th century, the solar system may have passed through a cloud of cosmic dust or an area of increased density of interstellar matter. Such an event could have led to increased meteorite activity, changes in solar radiation, and effects on the Earth's magnetosphere. Some researchers suggest that the cause of the catastrophe could have been the gravitational effect of a massive cosmic object passing close to the solar system, possibly a brown dwarf or a rogue planet. Such an object could not only have caused tidal effects in Earth's oceans, but also disrupted the orbits of comets, increasing their activity. An integrated analysis of all cosmic factors shows that the mid-17th century was a period of exceptional astronomical activity. Perhaps it was the combination of all these factors: solar flares, a supernova explosion, passage through an interstellar cloud, and the gravitational influence of external bodies that led to the global catastrophe whose traces we find in geological strata. The global catastrophe of the 17th century had a tremendous impact on the course of world history, although this impact remained underestimated by historians for a long time. Analysis of the historical processes of that time shows that many events, which are traditionally explained by socio-political reasons, may in fact have been the result of a natural disaster on a planetary scale. The 30 Years' War in Europe, which began as a religious conflict, became particularly destructive in the mid-17th century. Famine caused by climate change forced peasants to abandon their lands and join the ranks of mercenary armies. Cities that lost their trade links due to the disruption of river and sea routes could no longer support their former populations. This led to mass migration and social upheaval throughout Europe. In England, the events of the mid-17th century are traditionally referred to as the English Revolution. But analysis of economic data shows that the revolution was preceded by a period of catastrophic decline in agriculture and trade. Crop failures followed one after another. Trade routes were disrupted, and tax revenues fell sharply. In such a situation, conflict between the king and parliament was inevitable. the changes in the Netherlands were particularly dramatic. This country, which was experiencing a golden age at the beginning of the 17th century, faced serious problems by the middle of the century. Many polders were flooded. The merchant fleet suffered huge losses due to changes in the depths of sea routes, and fishing practically ceased due to changes in fish migration routes. In Russia, the time of troubles officially ended in 1613, but social upheaval continued. Stepan Razин's uprising in the 1660s was largely a consequence of the economic crisis caused by climate change. The Volga, the country's main trade artery, repeatedly changed its course, disrupting traditional trade links. China was experiencing the agony of the Ming dynasty, which formally fell in 1644. But the reasons for this fall are traditionally associated with corruption and external invasions. However, analysis of climate data shows that the decline of the dynasty coincided with a period of catastrophic floods and crop failures. Hunger forced peasants to join rebellions, and the state was unable to cope with natural disasters. In Japan, the Edo period, which is considered a time of isolation and stability, actually began with a series of natural disasters. The Tokugawa shogunate was forced to pursue a policy of isolation partly because the country could not maintain its previous trade links due to changing sea conditions and frequent tsunamis. In America, the conquistadors encountered a mysterious phenomenon. Many Native American civilizations suddenly disappeared or declined in the middle of the 17th century. This is traditionally explained by epidemics of European diseases, but radiocarbon dating shows that many cities were abandoned even before contact with Europeans. Perhaps a natural disaster dealt a blow to American civilizations from which they were unable to recover. In Africa, Portuguese explorers noted sharp changes in trade routes and population migrations in the middle of the 17th century. Many tribes living on the coast moved deeper into the continent. This led to changes in the structure of the slave trade and European colonial expansion. Changes in world trade are particularly interesting. The great geographical discoveries of previous centuries had created a global trading network, but in the mid-17th century, this network was seriously disrupted. Many sea routes became dangerous or impassable, depths changed, and tidal cycles were disrupted. This led to a reorientation of trade flows and a shift in the balance of power between maritime powers. Demographic data also show anomalies in the mid-17th century. Across Europe, there was a sharp decline in population, which is traditionally explained by wars and epidemics. But the geographical distribution of the demographic decline does not coincide with the map of military operations or the spread of the plague. Rather, it corresponds to areas that may have been affected by floods and climate change. Cultural changes of the time may also be linked to natural disaster. The Baroque style in art, with its drama and expressiveness, emerged in the 17th century. Perhaps it was an artistic response to the upheavals of the time. The literature of the period is full of apocalyptic motifs and reflections on the transience of human existence. The global catastrophe of the 17th century not only changed the course of history, but also had a profound impact on the development of human civilizations. Many of the technological, social, and cultural innovations of the time can be seen as adaptations to the new conditions created by the natural disaster. Humanity was forced to reinvent ways to survive in a changed world. Technological progress in the mid-17th century was clearly a response to the crisis. The development of more sophisticated methods of land drainage in the Netherlands was a direct response to catastrophic flooding. Dutch engineers created fundamentally new systems of dams and canals, to protect the country from a repeat of the water disaster. A real revolution took place in the field of navigation. Old sea charts became unusable due to changes in depths and coastlines. This stimulated the development of more accurate methods of cartography and navigation. It was in the 17th century that fundamentally new types of marine chronometers were invented, and astronomical methods of determining location at sea were improved. Agriculture also underwent radical changes. Traditional farming methods proved ineffective in the new climatic conditions. This led to the search for new crop varieties that were resistant to the changing climate. It was in the 17th century that potatoes, corn, and other crops brought from America began to be widely introduced in Europe. Architecture and urban planning also changed under the influence of natural disasters. Cities began to be built with possible flooding in mind. In Venice, new types of foundations designed for variable water levels appeared. In London, after the Great Flood of the mid-century, the principles of urban planning were revised. The changes in the social organization of society are particularly interesting. The natural disaster destroyed many traditional ties and hierarchies. Nobles who lost their lands due to flooding were forced to look for new sources of income. Peasants who lost their land moved en masse to the cities. This led to the formation of a fundamentally new social structure based not on land ownership, but on trade and crafts. Religious beliefs also underwent serious changes. The catastrophe of the 17th century was perceived by many as a sign of divine wrath or a harbinger of the end of the world. This led to the growth of various religious movements and sects. At the same time, more rational scientific thinking began to develop. People sought natural explanations for the events taking place. Science at that time received a powerful impetus for development precisely because of the need to explain and predict natural disasters. Galileo, Kepler, Newton, all of them lived and worked in an era when nature demonstrated its unpredictable power. Perhaps this is what stimulated their search for the natural laws that govern the world. Economic systems were forced to adapt to new conditions. The traditional feudal economy, based on agriculture, proved to be extremely vulnerable to natural disasters. This stimulated the development of a more diversified economy based on trade, crafts, and manufacturing. The colonial expansion of European powers can also be partly explained by the consequences of the catastrophe. Countries affected by floods and climate change were forced to seek new sources of resources and new markets. This accelerated the process of globalization and the creation of a global economic system. Interestingly, different civilizations reacted differently to the catastrophe. European countries focused on technological innovation and territorial expansion. China, traditionally focused on internal problems, plunged into a period of isolation and internal conflict. Japan chose the path of strict isolation, which allowed it to avoid external shocks, but slowed down technological development. American civilizations, already weakened by epidemics of European diseases, were unable to adapt to additional natural disasters. Many of them simply disappeared, leaving behind only archaeological monuments and mysterious legends about the time of the Great Floods. African societies responded with mass migrations deep into the continent, which radically changed the ethnic map of Africa and influenced the subsequent development of the continent. Many coastal civilizations were forced to reorient themselves toward land trade and cattle breeding. Thus, the global catastrophe of the 17th century became a turning point in human history, determining many features of the modern world. In the 21st century, the development of new technologies has allowed scientists to take a fresh look at the mystery of the 17th century. Modern research methods are uncovering more and more evidence that 400 years ago, humanity did indeed experience a catastrophe of planetary scale. Each new discovery adds details to the overall picture of the global flood. Satellite archaeology has revolutionized the search for submerged settlements. Using radar images from space, scientists have discovered the remains of hundreds of cities and settlements that existed in the 17th century underwater. A particularly large number of such discoveries have been made in the North Sea, where modern technology allows us to look under many meters of water and sediment. LiDAR imaging, a laser surface scanning technology, has revealed traces of ancient coastlines hidden beneath vegetation. This data shows that sea levels in the 17th century did indeed rise several meters above current levels and then fell. Such fluctuations could not have been caused by normal climatic processes. Deep-sea research using underwater robots has discovered layers of sediment on the ocean floor that correspond exactly in time to the mysterious clay layer on land. Analysis of these marine sediments shows that in the mid-17th century, processes of unprecedented scale took place in the oceans. Mixing of waters of different salinity and temperature, and the transfer of huge masses of sediments. Genetic studies of marine organisms have yielded unexpected results. DNA analysis has shown that many species of fish and marine animals survived a bottleneck, a sharp decline in population, in the 17th century. This could only have happened as a result of catastrophic changes in the marine environment. Paleoclimatic studies using the latest methods of oxygen isotope analysis in ice cores have confirmed the abrupt climate changes of the mid-17th century. But what is particularly important is that these changes were global in nature and occurred simultaneously in different parts of the planet. Modern seismological methods have made it possible to detect traces of powerful seismic events in the Earth's crust in the 17th century. Analysis of ancient earthquakes shows that between 1640 and 1650, seismic activity was abnormally high across the planet. Computer modeling of climatic processes has helped scientists recreate possible disaster scenarios. The most realistic models show that to explain all the observed phenomena, it is necessary to assume the influence of several factors at once: cosmic events, volcanic activity, and changes in ocean currents. Molecular biology has contributed to the research. Analysis of ancient DNA extracted from organic samples in the mysterious layer showed the presence of microorganisms that are usually found only in deep-sea trenches. How they got into continental sediments is a mystery that may indicate the mixing of deep ocean waters with surface waters. Geochemical studies have revealed abnormally high concentrations of rare earth elements in the 17th century layer, which are usually found deep within the Earth or in cosmic bodies. This could indicate either powerful volcanic activity or the fall of a large meteorite. Archaeological dendrochronology, the analysis of wood from archaeological sites, has shown that in many regions of the world, construction activity came to an abrupt halt in the mid-17th century, and then resumed using completely different architectural principles. This suggests radical changes in living conditions. Digital reconstruction of historical maps has revealed the extent of changes to coastlines. Comparing maps from the 16th and 18th centuries, researchers have found that many geographical features have simply disappeared or changed location. Such changes could not have occurred gradually. Interdisciplinary research combining data from archaeology, geology, climatology, and astronomy is creating an increasingly complete picture of the events of the 17th century. Each new scientific work confirms the hypothesis of a global catastrophe, although its exact causes and mechanisms remain a subject of debate. Research on coral reefs is particularly important. Corals are a kind of natural archive that records changes in the temperature and chemical composition of seawater. Analysis of coral colonies several centuries old shows sharp changes in conditions in the middle of the 17th century. Modern technologies allow us not only to study the past, but also to model possible scenarios for the future. Climate models show that such a catastrophe could happen again, and humanity needs to be prepared for it. The study of the mysterious layer of the 17th century and the events associated with it is of great importance for understanding not only the past, but also the future of our planet. Evidence of a global catastrophe 400 years ago forces us to reconsider many established ideas about the stability of natural processes and the vulnerability of human civilization. First of all, the discovery of traces of a planetary catastrophe in the 17th century shows that such events occur much more frequently than previously thought. If a geological layer of the same age is found across the planet, it means that nature is capable of catastrophic changes on a scale that modern science considered virtually impossible. The climate changes we are seeing today may not be unique. History shows that the Earth's climate is capable of sudden shifts that radically alter living conditions on the planet. The Little Ice Age of the 17th century was not a gradual cooling, but the result of a sudden catastrophe that changed the temperature regime of the entire planet in just a few years. Modern cities built on the shores of seas and rivers may be just as vulnerable as the settlements of the 17th century. The sea level changes that occurred over several years back then would affect billions of people today. Venice, New York, Tokyo, London. All these megacities are in areas of potential risk. Economic globalization makes modern humanity even more vulnerable to natural disasters than our ancestors were. In the 17th century, the destruction of trade routes in one region did not have a dramatic impact on life in other parts of the world. Today, a disruption in logistics chains can paralyze the entire global economy in a matter of days. The technological progress that we consider our main advantage can turn out to be a double-edged sword. Modern infrastructure, electricity grids, communication systems, transportation is extremely sensitive to natural disasters. A solar flare or magnetic storm could disable our entire digital civilization. 17th century research shows the importance of an interdisciplinary approach to the study of natural disasters. Only by combining the efforts of geologists, climatologists, archaeologists, historians, and astrophysicists can we obtain a complete picture of the events that took place. This is a lesson for modern science, which often suffers from excessive specialization. The issue of predictability of such events is particularly important. If the 17th century catastrophe was caused by cosmic factors, then modern astronomy should be able to warn of similar threats in advance. Systems for monitoring outer space, solar activity, and the Earth's magnetic field are becoming critically important. The social consequences of a global catastrophe also require serious analysis. The events of the 17th century showed that natural disasters can lead to the collapse of states, mass migrations, and radical social changes. Modern society must be prepared for such scenarios. Paradoxically, the catastrophe of the 17th century stimulated technical and scientific progress. The need to adapt to new conditions led to revolutionary inventions and discoveries. Perhaps modern humanity is also capable of turning threats into opportunities for development. Studying historical catastrophes helps us better understand the resilience of different types of civilizations. Those societies that were able to quickly adapt to changing conditions not only survived, but also grew stronger. Those that tried to preserve the old order disappeared from the face of the earth. The environmental lessons of the 17th century are also extremely relevant today. The catastrophe showed how closely all the planet's natural systems are interconnected. Changes in one part of the planet immediately affect other regions. This is important to consider when planning modern environmental policy. Perhaps the most important lesson is that humanity has already experienced global catastrophes and survived. Our species has proven to be adaptable enough not only to survive natural disasters, but also to learn lessons from them for further development. The study of the mysterious layer of the 17th century continues. Each new study adds details to the overall picture of events that took place 400 years ago. And although many questions remain unanswered, one thing is clear. Our planet is capable of catastrophic changes, for which humanity must be prepared. Knowledge of past disasters is not a reason to panic, but a tool for preparing for the future. History teaches us that civilizations that are ready for change not only survive, but also thrive. Perhaps understanding the events of the 17th century will help us better prepare for the challenges of the 21st century.